Let's look at Chief Mate Stability MCA Examination, March 2014, question number 2. It says, a container vessel's particulars in salt water are as follows. Displacement 16,000 tons, kg 8.10 meters, draft 7.40 meters, lateral windage area is 5160 meters square, centroid of the windage area 10.3 meters above the waterline. A. Construct a writing moment curve using the KN tables in the stability data booklet. B. Using the writing moments curve in question 2A, determine each of the following. 1. The angle of heel due to a steady lateral wind pressure of 48.5 kgs meter square. The angle of heel if wind pressure increased by 50% due to gusting. We'll first make the tables for calculating the writing moments. So we have the angle of heel and the values of 0 degrees, 12 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, and 75 degrees. Associated Kn values have been derived from the ship particulars as the following. The kg of the vessel was given in the question and it was given as 8.10 meters. So we will get these associated values by multiplying the kg times the sine of angle of heel. So if angle of heel is 0 degrees, it will be kg multiplied by sine 0. If it is 12 degrees, it would be kg multiplied by sine 12 degrees, and so on. So we have obtained the following values. For 0 degrees, it is 0. For 12 degrees, it is minus 1.68 because this sign is minus. So this would be minus 2.77. This would be minus 4.05. It is minus 5.21. It is minus 6.20. This is minus 7.01 and this is minus 7.82. These minus signs have been put because we need to subtract the kg sine theta from Kn. So we have put minus sign in front of kg sine theta, so it would be minus of the kg sine theta. When we take off kg sine theta from the Kn values, we'll get the associated Gz values in meters. But when we plot the curves for the wind heeling, we plot the curve for the writing moments. We don't plot the curves for the Gz values. This is totally wrong. We plot it for writing moments. So in order to get writing moments, we get it by Gz times the displacement of the vessel. So the displacement of the vessel was given as 16,000 tons, which has been put in all these angle of heel. And when we multiply this value by the following, we will get the associated writing moments. The second step is to plot the diagram. When we plot the diagram, this is our vessel. This is the draft line, which is 7.40 meters. This is the center of gravity measured from keel, which is 8.10 meters. And this is the center of gravity of the lateral windage area measured from the water line, which is 10.30 meters. The center of buoyancy measured from keel is unknown. We will first calculate the value of BG because that is what is required in the formula. So the BG distance is this distance. We can calculate value of BG by draft plus centroid of windage area above water level minus KB. So this is the draft of the vessel. This is the centroid of windage area above the water level, and if we subtract the value of KB from it, we will get this distance, which is BG, which is required. When we have put down this equation, which is BG is equals to draft plus centroid of windage area above water level minus KB, we know our draft, we know the centroid of windage area above water line, but KB is unknown. So to find out the KB, we will enter the hydrostatic data with the displacement provided, which was given in the question as 16,000 tons, and we will obtain the KB value by doing the interpolation. When we put in the values in this equation, we will get draft, which was 7.40 meters, which was given in the question, the centroid of windage area above water line, which is 10.30 meters, minus KB, which is 3.966 meters. This value has been derived from the hydrostatic data by doing interpolation against the displacement of 16,000 tons in salt water. We have obtained the value of BG as 13.734 meters. So BG has been marked in yellow, B has been marked in yellow, and this small g has been marked in red. So same here, I'm mentioning this distance. So B has been marked in yellow and small g has been marked in red. So this distance has been obtained as 13.734 meters. When we calculate the steady wind healing moments, the formula is given as the lateral exposed area multiplied by 48.5 divided by 1000 multiplied by BG. Lateral exposed area was given in the question, which was 5160 multiplied by 48.5 divided by 1000 multiplied by 13.734 meters, which was BG, which has been obtained from here. So the steady wind healing moments has been obtained as 3437.1 tons meter. The gust wind healing moments is obtained by steady wind healing moments multiplied by 1.5. So gust wind healing moments is 3437.1 multiplied by 1.5, which has given us the final answer as 5155.7 tons meter. We will now plot the righting moment curves, because this is the curve which is required when we do the calculation for the container vessels. So the righting moment curve is in blue color. The y-axis is the righting moments and the x-axis is the angle of heel. We have plotted the steady wind healing moments, which was 3437.1 tons meter in green color, and we have plotted the gust wind healing moments as 5155.7 tons meter, which has been plotted in red color. Now to obtain the angle of heel from the steady wind healing moments, we will follow the steady wind healing moments line and see at which point it intersects the righting moment curve. So in this case, this is the point. We'll bring this point straight down on the axis and note down the angle of heel. So in this case, it is 20 degrees. The same thing to obtain angle of heel for gust wind healing moments. We will follow the gust wind healing moments line till it intersects the righting moments curve. So in this case, it is at this point, and we'll take down the reading at the x-axis for determining the angle of heel, which is 27 degrees. So answer to part B1, angle of heel due to steady lateral wind, is 20 degrees. And answer to part B2 is angle of heel due to gust wind, which is equals to 27 degrees. Now some people might be thinking, why not we have plotted the GM value at 57.3 degrees. The reason is the GM value, which is plotted at 57.3 degrees, is only done when we plot the GZ curve. But right now we are plotting the righting moments curve. So we cannot plot the initial GM here.